Hello, good evening. My name is Diana Munn. I'm Director of Public Programs at the Harvard Museums of Science and Culture, and I am delighted to welcome you to tonight's lecture presented by the Harvard Museum of Natural History. Today we're celebrating Earth Day, but I would like to think that all of you watching celebrate Earth Day every day. Some of you may know that the theme for Earth Day 2021 is Restore Our Earth. This theme invites us to learn about natural processes, green technologies, and innovations that can restore the world's ecosystems. One of the greatest threats to ecosystems on Earth is agriculture. So we thought it would be relevant to invite agroecologist and soil scientist Dr. Jerry Glover to share with us some of the innovations that are improving agricultural practices around the world. Jerry is an internationally recognized thought leader in sustainability and agricultural research. A National Geographic Explorer, he leads international development programs that partner with small-scale farmers in developing countries to improve the health of their farms, their families, and communities. With a background in philosophy and soil science, his work has focused on finding better ways to produce food and to reverse global soil and land degradation. His work has been featured in publications such as National Geographic, Discover, and Scientific American, and he has published extensively in scientific journals. The journal Nature identified Jerry a few years ago as one of the 5 crop researchers who could change the world. We are honored to host Jerry tonight, who is joining us from Washington, D.C. Welcome, Jerry.
Thanks so much. I really do appreciate the efforts of the folks at the Harvard Museum to have me in, and just want to wish everyone a great, happy Earth Day. As a soil scientist, Earth Day is definitely a special day when it's a good opportunity to reflect about the importance of soils and the Earth more widely. I do want to just take a few minutes to say a little about myself and my passions. My background screen is a picture of a soil pit, one that I dug in my research projects. And over here on this side, that's the soil profile of a natural grassland system. You can see the roots going really deep in there, actually quite a bit below what you can see on the screen. And on the other side is the soil profile with annual wheat. I use that comparison in part because wheat is the most extensively grown crop in the world. And of course, it's an incredible supply of calories and protein for humans around the world. There's a lot of changes, though, that producing that wheat has brought to the planet. And of course, that's what I'm here to talk about tonight. In the opening, it was mentioned that agriculture poses one of the greatest threats, or perhaps the greatest threat, to ecosystems and biodiversity. And that always, I think that's true. It always hurts me quite a lot to hear that, because I did grow up on a farm. My passion is for farming. I do believe it can provide a great, wonderful livelihood for folks. And it's produced tremendous goods for humanity. So, it has that dual personality kind of thing going. And we need to find better ways to farm, but also ways to get around these negative impacts. Now, I will say I not only worked on a farm, but I also, as was mentioned, pursued it academically. I also worked for about 5 years in the restaurant industry in what I would consider slow food restaurants. So I'm also a proud member of the foodie community and certainly appreciate food as a cultural centerpiece, as well as the production practices. So I just want to point out, I have a lot of passion for farming as well as the food that it produces. Perhaps my greatest driving passion these days, though, is concern for the overall impacts of food production on the planet. But tonight, I think the message is going to be positive. I certainly have found some positive opportunities, and that's what I want to go through tonight, not just the downsides, but certainly the positive aspects of farming and food production, and I believe opportunities to really pursue some restoration of the planet, restoring some of the functions that have been degraded through agriculture and food production more widely. So with that, I'm going to share my screen. It might take just a second for that to load, so just be patient. And I will say, you know, it's quite odd, of course, for me to present in this environment where I can't see any of you. So please bear with me if there's some awkward moments or I'm hesitating. I just want to make sure I'm doing my best not to leave anybody behind. I have roughly 3 parts that I'll go through tonight, just an overview of these topics as I've given a brief glimpse of. And then some of the things that have taken up most of my time in the recent decades around improving farming systems around the models that were essentially developed in the 20th century. And then another part about the third part going into opportunities that I see for the future. Quite revolutionary, and actually quite much further along than what I thought when I first started looking into it. So again, in front of you on the screen is this soil profile. And I just want to point out that the rooting depth of this so-called natural system, natural can mean a lot of different things these days, but the roots going quite deep, that's more than 2 meters deep. These systems tend to be quite diverse. Even this relatively non-diverse system from Kansas would have in its natural state had several hundred species, plants and animals in its natural condition. The way it functioned is cycling nutrients very tightly, which means not many leaking below that surface or running off the, running through that system or off the surface. Many of these natural systems actually sequester carbon. A lot are kind of at a steady state to where they're not emitting greenhouse gases or, you know, at zero or even a sink. And of course, providing wildlife habitat. I think that's quite a marker these days for the functioning of a system, is the support of the wildlife in the system. In contrast, that agricultural system, you know, even the more diverse agricultural systems I've seen, you know, maybe a dozen, maybe at the most extreme, a couple of dozen plants and animal species in the agricultural system compared to several hundred, or in many ecosystems, more than 1,000. So 2 or 3 orders of magnitude less diverse in most agricultural systems. Very loose nutrient cycles. For example, farmers will put nitrogen on to boost plant growth. Typically, more than half of that nitrogen that's supplied runs through that system and is lost to the surrounding environment. Agriculture, I'm sure as many of you know, contributes a lot to greenhouse gas emissions around the world. And as was pointed out, you know, it's the production of food across these large landscapes that reduces wildlife habitat and is one of the biggest threats to biodiversity. So with agriculture, we're really changing the surface of the planet. You know, some 35% of the planet's surface now is dedicated to food production, largely for humans. Not all of it really efficient, but it had, you know, food production systems are now the largest biome on the planet. So highly impactful. Now, those were kind of the bad things about the agricultural systems and the great thing about natural systems. But we do have to face the fact that these agricultural systems supports our global civilizations. some 70 to 80% of our human calories come from these land-based agricultural systems. And only 3 crops actually provide the vast majority of those calories. In many of the places where I work, agriculture is a huge livelihood source, producing not just the food that people eat, but for sale, bringing in extra income and so on. And one of the things that I find as a sort of an agricultural ecologist and so on is just the remarkable way that agricultural systems have been developed to concentrate essential nutrients, build proteins using plants that over time have been domesticated, animals that have been domesticated, and just so that we can really concentrate those and consume them. And, you know, if for you parents out there watching your children grow, that's the source of the calcium, phosphorus, potassium that builds the muscles, the bones, and so on. Most of that ultimately comes from the soil by plants concentrating it from large landscapes and then kind of through miraculous processes, making it digestible by us, and often though through a complex processing system and transportation system and so on. So those are kind of the differences. But in general, agricultural systems, when we convert natural systems to agricultural systems, quite a lot of damage is done. And when we talk about natural systems, you know, those perennial based, by which I mean those plants are living in the landscape year after year, protecting the soil and so on, and diverse. So perennial and diverse versus not diverse, often monocrops and short-lived plants. Lots of disturbance in those agricultural systems. Now, I have seen some very elegant exceptions to those rules, but those are the general rules around the world and common to most of our agricultural systems. Now, I'm not going to get a lot into these sort of what I think of as 20th century controversies, agroecology versus sustainable intensification, organic versus conventional. I've worked on both sides of those versus statements, and I think I can lay out pretty clearly the pros and cons of each side. So what I'm going to focus on tonight is just kind of the general principles around agriculture, some general principles about how we can improve agricultural systems, but more importantly, maybe the ultimate failure of them to do what I feel is needed, based in terms of restoring the planet to a much higher level of functioning, a much higher level of biodiversity. So whichever side of these dichotomies you stand on, I'm often there with you because I do see pluses and minuses to both. But, you know, whatever side of those dichotomies you stand on, when we talk about croplands, a big feature of croplands in general are these cereals, oilseeds, and pulses. And those are pretty much all annuals. They make up about 68% of the croplands around the world. And that's where most of the problems related to agriculture is. So one thing I think is that we could probably solve all the problems in fruit and vegetable production, roots and tubers, you know, those crops that you typically see at a farmer's market. And it wouldn't really make a dent in the extensive damage done by agriculture, and nor, of course, would it edge out the tremendous benefits from the cereals, oilseeds, and pulses. So it's really that big slice of that pie there that I'm addressing tonight and considering in terms of the future options. Okay, so one thing to keep in mind is that the basis of our civilizations currently, the foods that support them, primarily are based on a few dozen plants and animals that were domesticated thousands of years ago. We have largely had a steady source of food for the planet. And some places, live a lot more on marine fisheries and so on. But by and large, the major civilizations, and certainly currently, rely heavily on those small handful of crops, annuals that are produced in low diverse conditions typically. And again, that's kind of the source of the problem. Now, for a long period of time after the domestication of those crops and animals, the biodiversity losses around the planet weren't that great. In part because the extensive nature of croplands wasn't so great. Biodiversity losses were often localized and fairly slow. But roughly 50 years ago, the global biodiversity losses began accelerating at an alarming rate. And it is pretty striking to look at the long-term graphs over time about that. And I kind of use 1970 as a benchmark. So when I think about restoration of ecosystem function and biodiversity, I think for me, that is a great benchmark to shoot for. And I will say that's not a benchmark for success that many of my colleagues in the agricultural sciences use. And I'll explain more on that in just a minute. But here is that steep decline from 1970 onwards. Quite a loss. This is from World Wildlife Fund's Living Planet Index, which I think is pretty robust and pretty sound. And they have some nice solutions that they suggest: greater conservation, improved production practices, improved diets, and so on. I think we need to be doing better than that. Frankly, the best case scenarios indicate that we might bring back up this the level of biodiversity to this green level, over the next 50 or 100 years. And frankly, I'm pretty skeptical, because that's if everything goes well. Right now, we're facing a climate crisis, as I'm sure most of you know, and that makes growing food in many parts of the world much more difficult. So even as scientists boost yields, decrease the environmental impact of our crop production, we're fighting an uphill battle against climate change in many places. For the thousands of years in which agriculture has been a dominant feature of civilization, it's operated in a fairly stable climate, much like it is today. And so there's not much wiggle room in many places with changes in climate that will effectively reduce yields. And already we're facing, through population growth and landscape degradation, the need to go onto better lands, which there's not much left, and expand cropland as it is. So I think that green line there is kind of a best case scenario under current under those 20th century models of food production using those long domesticated plants and animals. Okay, now having said that, there is room for improvement, and that's where I spend most of my time looking at ways to improve them. And we have come a long ways. And again, whether you're talking organic or conventional, agroecology or sustainable intensification, we have a much better array of tools and solutions that we're working through. And we take a much more nuanced perspective, I think, these days than we did, say, in 1970. For example, with the Green Revolution, it was often just productivity. Bushels per acre, tons per hectare, that was kind of the measure of success, which at the time, that really did help, that focus really did help us get through some tough times with the growing population and increasing food scarcity. However, now, we realize that we have to take this more nuanced approach to things, considering social equity, social capital, the human condition. It's not just about calories, it's about a balanced diet with nutrient-dense foods. We cannot ignore the environment. We have learned the hard way that if we ignore the environment, the damage done long-term to the environment, our productivity declines. We have to abandon whole landscapes, seek new lands to go onto. And rather than farming on the best lands, we're oftentimes forced to farm on very marginal lands because we destroyed or damaged the better lands. And of course, farmers, farmers have to make a living and they need income. And so it has to fit within an income generating model, or the whole thing kind of falls apart. All those elements are essential and critical, and we're doing a much better job, I think, collectively around the planet of getting all those elements in place. Of course, that begs the question, well, what does that look like? Well, we can think about three broad areas of the inputs, if you want to call them that can improve agricultural systems. The socioeconomic factors, such as the markets, the infrastructure, roads, the enabling environments that provide better information, better governance. And of course, the very important, at least for my work, ecological factors, using sunlight more efficiently, using water more efficiently, improving the nutrient flow through the system so that we're not losing so much. A lot of it hinges on crop and livestock diversification. So a lot of those very interesting elements that go into improving the system while taking advantage of the greatly improved crop genetics, the traits that are now able to be introduced into crops to better tolerate heat, drought, pest and disease pressures, and really a game changer. But of course, the genetic factors alone don't work very well if you're not also improving the ecological system, ecological functioning of the system, and ensuring that the necessary socioeconomic factors are in place. In a nutshell, that's how we're improving the sustainability and the productivity of these. Now, I want to make sure that you get a concrete picture of that, because that's quite abstract. It's a lot of words that can have different meanings. And I want to use the case of Rhoda Manana in Malawi. And she's going to maybe appear to many of you as a very special case, but I think this story has so many elements common to agricultural systems around the world, including in the grasslands of the U.S., where wheat's being produced on large farms. Just a lot of elements that Rhoda displays on her farm that reflect good general principles of farming in most other locations, even though those locations are very different, and the socio-cultural conditions that Rhoda faces are quite different as well. So let me just go into a bit of details on what she was facing. She was quite poor. Her family was quite poor in Malawi. Her husband had outside work off the farm, but he was bringing in income. Sadly, though, he died, which left all those responsibilities for school fees, the goods and services that improve people's lives. She now needed to use her farm to generate income to supply those. Very poor yields, very degraded lands that she had access to use, and it was low soil fertility, low soil carbon, lots of continued years of growing crops on there, harvesting the crops, taking it off without returning nutrients. So she was faced with very low yields on that crop. Now, you remember that diagram where I showed you those 5 different domains. One of those is the social element that is just critical. We increasingly appreciate the social capital that's needed to really support and enable farmers. Because she got in touch with a local non-governmental organization, and there were some publicly funded extension agents available, they introduced her to new information, and they showed her how to plant these trees that she introduced to her farm. And this is where it's getting more interesting for at least me, an agricultural ecologist, planting trees in your farm field. Okay, so, and here this gets into the environmental benefits. Carbon sequestration. Now, for those of you familiar with growing corn, this is a truly amazing picture, because these, I think you can see my cursor, these corn stalks are growing right next to very large trees. Here's the canopy in the background. And when I saw it, I was like, wow, how is that even possible? You would think that the competition for resources, sunlight, nutrients, water, would be so intense that those maize plants would not have a chance. But here's the incredible thing. Those are called fertilizer trees, and the genus is Phyderbia. These are quite well known around Africa because they drop their leaves. The trees will look dead when farmers are planting their maize. So when the maize is growing, the trees are not growing. They're not shading. They're not drawing up water. They're not competing for nutrients. You can see in this photo, the maize is ready for harvest. She was harvesting it when I visited her farm. And you can see that the leaves have now emerged out on the trees. And so that'll be a nice closed canopy just from trees in between the corn growing. So the trees are protecting the soil cover, the soil surface when there's no maize growing. About the time that she's ready to plant her next crop of maize or whatever other crop she's growing, those leaves will fall off. They're very rich in nitrogen because this tree is able to fix nitrogen from the atmosphere. And of course, mining phosphorus and other essential plant elements from deep within the soil, bringing them up into the leaves, and then when the leaves fall, it fertilizes the next crop. Really beautiful, elegant system, very exciting. I have some links that I'll send out after this talk that will give you some video links and some actual papers with more technical detail. Anyway, I had some grave diggers dig a hole because I was really wanting to know what was going on below that soil surface. You can see these large tree roots reaching really deep into the soil. These maize roots are probably only reaching down to about here. But with these trees, it's really extending the soil volume available to that whole farm. So really boosting productivity. She started investing in improved maize varieties so she could grow more using less fertilizer. And she was able to afford other fertilizers that would balance out her soil even more. And it had all these knock-on effects because the trees weren't just fertilizing her maize, but they were also feeding livestock. So she's getting more income from her maize and other crops. Her soil's improved. And now she has this valuable livestock forage that she can use. So she reinvested in her farm, buying pigs and goats that could use the crop, the tree leaves. And I'll tell you, it's a lot easier to make money off of livestock, a nutrient-dense, high-value enterprise compared to maize. That was really a game changer for her economically. And that enabled her to afford school fees and the other necessities of life. That results in this virtuous cycle. The pigs and goats providing more manure that she can put back onto the ground. And as importantly, she no longer has to remove all the maize stalks and leaves from the field to feed to her livestock. She can get that fodder from her trees. So that allows that nice soil cover of crop residue down there. So anyway, there's the productivity, multiple fold increase in productivity using nice, sound ecological principles, the relying more on a social network of to enable her to do more, and bringing in improved genetics for better maize yields. And of course, all that really transformed their condition there on the farm, improved diversity of food, more self-reliant, greater income, and so on. Rhoda will probably not be wealthy from all this, but her kids have many more opportunities now to advance through the educational system, maybe return to the farm for some of them, others going on to other things. Now, I want to quickly move on to another area that I've worked in and I think has some real potential as well. As I mentioned earlier, most of our agricultural systems feature annuals grown in monocultures or low diversity situations. Farmers having to replant every year, the short-lived annual crops exposing the soil surface and so on, produces a lot of the bad outcomes that we see. So there are scientists around the world looking to develop perennial versions of the major grain crops. And if they are able to do that, and they certainly are able to produce perennial versions, but I should say they're still working to make them more competitive and equally viable in terms of economics, productivity, and so on as their annual counterparts. So here's Dr. Dhruva Thapa in Nepal. He's a plant breeder, and he's been looking at hybrids of domesticated annual wheat crossed with wild perennial relatives, traditional breeding, and getting some results there, hopefully with benefits to the soil, the farmers in the region, and so on. I haven't checked in with him, but he's one of quite a few around the world now working on this program. Just to highlight some of the differences, this is annual wheat. I think you can see my cursor. Soon after being planted in the fall, this is a Kansas winter wheat system. Its wild counterpart is this perennial wheatgrass, which you can see persists throughout the year. Fall, winter, spring, summer. The wheat, the annual wheat, and again, remember, wheat is the most widely grown crop in the world, occupying more land area than any other. And you'll see that after it's harvested, so once the grains are mature and the farmer goes through and harvests it, there's nothing living left in that system. So it's not pumping anything down below ground, not capturing any sunlight, and as importantly, not protecting that soil surface. So developing viable perennial versions of the major grain crops could be a huge breakthrough. And there's work going on a range of crops, legumes, oilseed crops, sorghum. Some of you may not be familiar with sorghum, but it's one of the most important staple food crops in large areas of Africa, Asia, and so on. Rice, maize, and wheat, those big ones. And there's quite good success on rice in China, quite good advancements on some of these other crops in other areas. Now, let's get back to this though. So even if those things go pretty well and we are collectively able to improve our efforts here, I think though we're still, it's going to be a stretch to even make it to this green line in terms of biodiversity. Now, I'm not going to claim that I have extensively modeled that, but I think the best estimates, and I've seen a few different reports, with the growing population, the pressures of climate change, the other stressors on the systems that we face, it's limited how much restoration we can actually achieve. I'm confident we can slow that decrease, maybe even plateau out. But thinking about the biodiversity of the planet, when I was a kid, and I have 3 teenagers, and what level of biodiversity they're going to be facing when they're my age, 30, I'm not 30. But thinking about that, I don't think that this green line here is good enough. I want something better. And when I think about Earth Day and restoration, I think we have to think bigger. And there are opportunities, quite exciting, I think, based on a couple of quite exciting revolutions I see. The first one, which is really significant, is this domestication revolution that's happening with microorganisms. Domesticating microorganisms to produce the specific proteins, fats, and carbohydrates that we want and get from these long domesticated plants and animals. More on that in a minute. That's accompanied, though, with a processing revolution. There are advances in processing now, including at the molecular level, that make it possible to make familiar and brand new foods from new and more sustainable sources. So rather than just rely on these few macro plants and animals that we have been relying on, we've been relying on a few dozen, often less than a dozen species from that. We now have the potential to go through another domestication revolution, but with hundreds or thousands of species. And when I first started looking into this, I thought, well, this is kind of way out there. And frankly, there were some, wearing my proud foodie cap, I was thinking, whoa, I don't know if this is going in the right direction. However, I looked into it a bit more, and I think it's further along than what I was aware of. Certainly further along than I would say most of my agricultural science colleagues are looking at. So one of the things boosting this came out of this massive ramp up to fund biofuel research. The fear of the peak oil, the fear of rising fossil fuel-based energy sources, and of course, the concerns about greenhouse gas emissions from these. And that massive influx of money really sparked this microorganism revolution in terms of domestication. Here's just one facility. There's quite a few different ones. I think this one specifically for biofuels, and is several years old. However, some of you may be more familiar with some of the alternative foods coming out on the market. This Impossible Burger, for example. It's made primarily from plants, but interestingly, they used one of these new processes and domesticated microorganisms, if you will, going through a precision fermentation process to really generate to synthesize the right proteins that we want, that we seem to savor from meat. So the advances, the processing, and the micro domestication really made this Impossible Burger possible. For me, it's the interesting thing. It's not the soybeans or the other types of plants that produce most of that. It's the other processes that made it more palatable in our diets. Amazingly, too, I mean, this is incredible. There are domesticated microorganisms now that can produce the same proteins that cows produce in their milk. And of course, it shouldn't be that remarkable, because we have to remember, it's not really the cows producing this. They have very complex guts that support very complex microorganisms, using the same thing but without the cow. And of course, it's the cows. Livestock production produces a lot of greenhouse gas emissions and so on. Now, just as another example, I realize this isn't food, but it is agriculture. There's now molecular processing methods to capture the flavors, the flavor profiles, the aromatics that comprise the foods that we really like. Atomo, you can look it up. What is molecular coffee? It's coffee without the bean, dude. And I certainly am cognizant of the important value of coffee production to smallholder farmers. But if we can find alternative livelihoods for smallholder farmers, or they can themselves, rather than producing large plantations of coffee, that could have quite an impact. Shouldn't just focus on the coffee aspect of this, because this has great potential, I think, for many other food products. And of course, processing, 3D printing. It's quite remarkable, the matching up now of domestication processes for these microorganisms paired up with the physical processing to make them much more palatable, desirable, and so on. Now, all that seems quite scary. It was kind of like, I love the food culture. So I was thinking, where is this going? So I searched out somewhat nearby facility relying on microorganisms to produce products, essentially domesticated fungi to produce products. And, it looks kind of scary, but, when you step back and think about the products and the reality coming out of this, it's actually quite familiar, because what I just showed you is the craft brewery just down the street from me. And of course, as we all know, brewers have been using semi-domesticated yeasts for thousands of years. What we're talking about now is some tweaks to those. Instead of semi-domesticated, working with what the yeasts produce, we're now talking about changes in those microorganisms that can produce more different kinds of food goods that we want. It's not just beer. Beer is very simple, but beer makes it familiar, I think. And anyway, the goal is in those previous photos, you'll see I have the life gap when there was quite a gap over what's between 1970 and now. I had life in parentheses showing that it's negative. Currently, our life gap is negative. I want to aspire to a positive life gap where we're restoring biodiversity back. It's not just biodiversity, it's all those important ecosystem functions that we've really cut into through our widespread food production. Now, I just want to leave it with, pulling out and with a little perspective. Years ago, I saw somebody put together an illustration of the volume of liquid fresh water, and the volume of the atmosphere, if you stripped it off the planet and put it into a ball, and then its relative size to the size of the planet. The striking thing there is wow, we have a very thin veneer of water, thin veneer of atmosphere around it. But I wish I could interact with you, because my question to you would be, what's missing from this illustration? Well, I'm a soil scientist, so you can probably guess. When I calculated the depth of soil available for agricultural production, and I even gave it quite a bit more. I gave it 2 meters. Most of our farmlands don't have 2 meters of soil available. And we put it into a volume. That's what we're working with, that small, tiny ball there that's available. We're losing it. It's degrading. We need to make some severe changes. But with that, I'm optimistic that there are many exciting opportunities, and I see them coming online more quickly than I would have anticipated. So it's not all bad news, but we definitely, I believe, need to shift what we're doing in terms of our food system and food supply. With that, I want to wish everybody a great Earth Day, of course, every day. Thank you all very much.
Thank you, Jerry. I learned a lot. I really enjoyed learning about your holistic approach to understanding agriculture. I think that is really really fascinating. And not, I'm a botanist, and I don't think about agriculture in that way. So I learned a lot from that. And I was really excited to learn more about these, how shall I call them, molecular foods. So how long is it going to take for these foods to enter the market and for people to, try these things out? Because I imagine that there will be a lot of questions. People may wonder about how they're produced, and they might be afraid of trying them out.
It would just be a guess about how quickly some of these products could come on. It's my understanding that for the dairy products, and by the way, it's not like soy milk or almond milk. These are the same fats and proteins produced by cows, but produced through microorganisms. So the consistency of the cheese is similar, the taste profile and all that. So pretty remarkable. It's my understanding that the cost, the cost is dramatically coming down and could match that of real cow milk quite soon. At which point, it might be very disruptive, and that is one of my concerns, and I'm exploring that. What is going to be the impact on the farmers who I love, and the smallholders who have few options to move off the farm and do something else? If now for urban consumers, less expensive, more environmentally friendly foods that are more nutrient dense, that sounds like a great thing. But when we think about these disruptive technologies, it can have very, very negative impacts on the livelihoods of many people. So, I think it could happen quite quickly with some things. I think the next 5 years will be quite telling, because there's such a push now globally to find improved environmental solutions, and a greater realization that climate change is impacting our ability to produce foods in the same old way. But I'm hoping that, like in 10 years, we'll see quite an expansion of that entry into the market.
Okay. I'm excited. I'm going to be looking out for that Impossible Burger.
No, the Impossible Burger's already at Burger King.
Okay.
No, I'm serious.
Yeah? Wow. Okay.
It's in the stores.
Okay. I definitely have to try that. So we have a lot of questions coming in. So let's address a question submitted by Holly. She asks, could you address the place of animals such as cows in smaller, I'm thinking local farm systems in the United States? Don't they, or can't they, contribute to soil health, putting the manure back into the soil?
Absolutely. I have a tremendous good friend. He's a rancher in Kansas. It's a beautiful scene. Thousands of acres of native grassland with wind turbines that generate a lot of electricity for a lot of households. And it really is kind of a model for improving agriculture as it is now. And that is a landscape that would not be good for producing crops. So that's grass-fed beef production like that is quite good. But what he doesn't have he has cattle, doesn't have the bison, the wolves, the dozens of large mammals, the extensive reptiles and so on. It's still quite it's still not a diverse system in terms of overall, but it does pretty well. I certainly think about him when I think about these potentially disruptive technologies coming online. In the smallholder systems around the world, livestock play a tremendously important role, able to concentrate nutrients from parts of the landscape where they can't grow maize. Very valuable, much better income, much higher nutrient density. Some downsides to livestock production, as I think we're probably well aware, but there's some great positives as well.
Okay. Byron wants to know, what is the risk of lateral DNA transmission between the manufactured microorganisms and their wild counterparts?
Well, I think there's some unknowns on that, but we're doing, I guess one way to put it is we're already changing these communities quite a bit anyway. So, a microbial community producing these fats and proteins to make micro milk, escaping out into the environment. I don't think there's nearly as much risk from that as the risk of continuing to devastate large landscapes where the damage is known, it's measurable, versus some of the unknown risks, perhaps. Although it's not, using these microbial communities is not brand new. We're pretty familiar with the risks involved, and they're much lower than the risks we already have from food production.
So there are a number of people who, like me, are wondering about whether the fake dairy products contain lactose. Are these products better for those of us who are lactose intolerant?
That's a great question, and I don't know. But I will say there's much greater opportunity to fine-tune these microbial communities to produce the right things and not produce the wrong things, depending on dietary needs. I have several stories that I could go into about the potential on that, which is quite extraordinary. So I don't know about lactose specifically, but it would not surprise me if that would, they could change the products being produced by these microorganisms. Now, lactose-free milk I don't know. That may be quite a different thing. I'm not sure.
Okay. So Jen wants to know if these microorganisms produce greenhouse gas. If so, please compare to current producers. Yeah. And thanks for a fascinating lecture.
Oh, well, thank you. I was really pleased to be here. I'm looking more into, I guess you'd call it the life cycle sustainability of these different approaches, and there's several unanswered questions, and that would be one of them. But I think that information is pretty compelling that greenhouse gas emissions could be much lower depending on what we're talking about. And I'm not just I shouldn't just focus only on the microorganisms, because people are now quite advanced in discussing and producing goods from insects. So, when we think about the domesticated crops and livestock, those are the vertebrate animals, mammals mostly. And so now people are really moving quite rapidly with insect protein, which is quite sustainable. And I think those systems actually could sequester carbon.
Yes, I'm a big fan of insects. I eat crickets with peanuts. They're delicious. Cycads, those are good. Now, Madeline is a fungi lover, like I am too. And so she wants to know about the future of fungi in soil health and agriculture. She's heard some interesting things, but she says that basic things like mycorrhizal fungi are underutilized. Do you think that there's a future, there's a place for fungi in improved food cycles like Rhonda's?
Yeah, and that's where the exciting discussions around the microbiome in the soil system is quite well. At least there's opportunities there, and I will say one of the reasons in general that those fungal associations aren't so widely utilized in agricultural systems is the nature of the annual crop life cycle. There's too much of a boom and bust cycle, I think, in those soil systems where you have, well, look behind me. Look at the below ground biomass over here. Those plants are pumping plant sugars, carbohydrate. They're feeding the soil tremendously. There's 10 times the biomass, well, often 10 times, 5 times, at least 5 times the biomass below these perennial plant communities than under our annual agriculture. So the annual cropping system is not feeding very well that below ground biome. And moreover, there's quite a bit of disturbance. And what we've seen with mycorrhizal fungi and so on, they're sensitive to disturbance. So I think one of the opportunities is if we go to more perennial systems, there'll be much greater opportunity to utilize not just below ground fungi, but actinomycetes, whole spectrum of bacteria that we don't see utilized nearly as well in annual crop systems.
So I noticed that there weren't a lot of questions about these perennial plants, but I definitely am very curious about them. Are there places in the world that are trying these plants out more than others? I mean, is this happening in the United States or elsewhere?
Well, certainly the pioneering organization on this effort is the Land Institute in Salina, Kansas. I used to work there. Great group of scientists there, and they are looking at a spectrum of them. Patagonia and some other companies have supported the development of a perennial version of wheat, Kernza. And you can actually buy products. General Mills was quite interested. My first modeling opportunity, you may be surprised that it was also a model. It was actually, they just used my image, Patagonia, to promote long root ale made with Kernza. In China, there's much greater progress on perennial rice, which would be a real game changer if that was able to be scaled up and spread more widely. So some of it is in the marketplace, very limited in the U.S. Now in Africa, one of my favorite systems, and I wrote this up in a couple of papers. It's based on pigeon pea, which is perennial but typically grown as an annual. But pigeon pea can survive multiple years. It's a short-lived perennial, so it's not going to live 50 years, but it can live 2 to 3 years. And traditional farming practices often integrated the perennial life cycle of that pigeon pea into the annual cycle of maize cropping. You get a nice 2 years of pigeon pea intercropped in one of those cycles with maize. And then colleagues of mine worked with the scientists there and traditional farmers to improve that system. And now it's a recognized best practice of the Malawi government and is quite useful in Zambia as well. So limited, but certainly viable. Beyond proof of concept.
So, Gary, if you have a few minutes to stay with us, there are a few more questions. Are you okay staying on for a few minutes? We still have an audience.
I sure am. And I appreciate the interest. And I had intended on ending earlier, but I got carried away in a few places and went on.
No problem. So this is a question from Ashton. How far from the future would we be to see that the entire world's food system becomes sustainable? Is that even possible?
A very interesting question, but I spent a lot of time with colleagues trying to establish, what is ultimately sustainable, and I gave up on that. I don't know what is ultimately sustainable, but because our populations are changing, the pressures are changing. It's a dynamic system. we have challenges that arise new that changes the sustainability equation. And we're in a very dynamic situation now. If the population was much lower, if we get out beyond population peak and we get out another 50 or 100 years where we're to, a stable population of 6 billion, that's a much different sustainability equation than where we are now, where we're building up to 9 billion in the face of a climate crisis, degrading landscapes, a biodiversity crash. So, it not only has to be sustainable now, but it has to be restorative. Which is, sustainable is kind of like, ooh, we're cruising along, but restorative, man, you got to do extra work.
So talking about the population, there are a couple of questions about how this new style of food production will be accessible to the billions of individuals who are living below the poverty level, right? How are marginalized people going to benefit from these new systems?
Yeah. Well, ultimately, that's going to depend on the the cost of production. And I have read what seem like credible reports that, for example, especially in the dairy sector, within a few years, they could be beating the cost of production of cow milk quite easily. So if these new disruptive production practices are producing essentially the same dairy products, but at 75%, 50% of the cost of cows, and there are other maybe environmental incentives for more sustainable production, then it's kind of, you wonder, is it game over for large scale dairy production? And what does that mean for the urban consumer? That could be huge, great news. If you're spending 75% of your income on just basic food and your price drops by 25 or 50%, that opens up whole new opportunities for you. If you're on the farm and you're barely making a living at the current market value, and the price drops by 25%, that's terrible. I mean, what do you do for income? So yeah, I mean, I'm really wanting to start addressing those kinds of implications, and that's where I think some and it's different on the development front, right? Poor people versus wealthy people. What's the impacts on social justice, I think could be quite profound. Food production, not just the consumption of food production, those impacts ripple across our entire society. Even though in the US only 2% produce the food, but there are all these production, processing, distribution ripple effects that could look quite different. And I don't know. I should have just said I don't know.
So Tara wants to know, so what about in the United States with small scale farmers or backyards? There's so much focus on lawns. What can people do on a small scale? And I feel like every Earth Day, or maybe every day, we're all asking ourselves, what can we do, right? What can we do at home? And then you have all those that say, what you do at home, it's just not going to impact the big picture, right? And so that leaves many of us frustrated. So what words of what suggestions do you have for what we can do as individuals?
Hey, I love to garden. It's one of my, certainly one of my hobbies. And more than that, it's part of my sort of foodie persona. But it's not nothing, I mean, you may not be ultimately, decreasing greenhouse gas emissions and all that. But what has changed the landscape of opportunities for changes in food production and the food system overall is increasing awareness by consumers. And of course, the challenges in the overall system, but consumers that kind of have an understanding of what the hell it means to get a plant to concentrate sunlight, soil resources, and produce something that you can eat. That's pretty profound in itself. And it can make you appreciate the challenges, but also the importance of that whole process from seed. We typically say from farm to fork, but it's from seed to fork. It's the full thing. So it's not nothing. Growing a garden's not nothing. I think becoming more aware of the relative impacts. So one part of that question was like, well, is that important enough? Well, I think becoming more aware of where the levers of opportunity are to make a difference is important. Probably too often we spend a lot of time, just kind of tweaking small things, trying to feel better about, trying to feel more relevant, trying to have more impact. But some of that effort should be spent on figuring out what the most important thing is. Getting on the plane. Get on a plane. You've blown everything. And I'm saying that from somebody who travels, or prior to COVID, I traveled quite a bit. You get on one plane and there goes all your other efforts, pretty much. I mean, it'll wipe out a lot getting on a plane.
And fortunately, many of us are not traveling these days. So if I could ask you two more questions, one from Renee, who is curious about pollinators and what you think about, are they doomed, or are there particular bee species like Africanized killer bees that hold potential?
Africanized killer bees are used as pollinators in Africa quite extensively. There's they'll have these beehives up in trees, and those are the ones that we fear, but they're pollinating crops quite widely. I fear for not just pollinators, but a lot of other species if we don't. And now it's not just stopping the expansion of agriculture, but we need to shrink it. And the best thing that we can do for pollinators is to shrink the extent of croplands on this planet. Period. Because just about any system other than an urban setting that replaces agriculture is more diverse. The best way to support pollinators is with plant diversity. And you just, if you stop farming a landscape, it will return, other plants will come in. And I almost guarantee you in every case, there's going to be a lot more there for a pollinator than when it was farmed. I've seen some exceptions to that, but not, that's rare. And it's often an exceptional farmer that can manage that complex of a system. And we cannot we cannot develop food systems based on extremely exceptional individuals and extremely exceptional circumstances.
So talking about exceptional circumstances, during the pandemic, we've seen that people have started their own gardens at home. This was this thing, right? Everyone was buying seeds right and left. I think that people gained a new appreciation for farmers, people who produce our foods. Do you think that this is here to stay? Is it going to continue?
Well, I think there'll be some lasting positive effect of that. I was caught up in that. I couldn't get seeds. I have my regular seed ordering schedule, and when I came to buy seeds, they weren't there. Really amazing. So yeah, I think I've seen friends that got into gardening, and I think they'll stick with it. I think it'll be, I think COVID has changed a lot for us in many different respects. One of my concerns is that as people garden, they think that those are the crops that farmers produce. Some farmers do produce those. You go to the farmer's market, the stuff that we grow in our garden is typically what we see at a farmer's market, right? I'm not growing wheat. I'm not growing corn. I'm not growing rice. I'm growing tomatoes and carrots. But, when we think about, again, going back to that pie diagram, it's those broad-filled crops: wheat, rice, maize, sorghum. I mean, there's like 10 of them that make up that 68% of our croplands. So, it is important that as we garden and appreciate that, which I'm all for, we don't lose sight of it's pretty far removed from the experience of most farmers on most of the land.
Okay. Well, Jerry, I really appreciate you taking the time to share your expertise with us tonight. I hope that everyone is inspired to learn more. And I really also want to thank you for everything you do to investigate these topics, to bring about change. I think it's wonderful what you're doing, and I'm looking forward to trying new foods. And I will be searching for that Impossible Burger. And
it's at Burger King.
Okay,
I'm serious.
Since you are in DC, I mentioned earlier that I liked insects, and I think I said that I like cycads, but it wasn't cycads. It's cicadas.
They're coming out.
They're coming out. They are so tasty. Dipped in chocolate. They are amazing. So I hope you get a chance to try them out.
Yeah, and well, thank you for letting me participate. I really just so sorry I can't see anybody, can't interact with you more. I look forward to meeting you all in person sometime, not by getting on a plane. But anyway, I wish everybody a very happy Earth Day and peace.
Thank you so much, Jerry. Have a good night, everybody.